42-inch OLED panels manufactured this year will cost 33% less than 55-inch OLED panels, according to a new cost analysis report. Will a price of $1,000 for a 42-inch OLED TV make you tempted? Let's discuss in this video. Hello everyone, Vincent Teo from HDTV Test here. Display Supply Chain Consultants, or DSCC, has published its Q4 2020 update to its Advanced Display Cost Report, and there are three main pieces of information I would like to cover in this video. 1. The cost of the upcoming 42-inch OLED panel. 2. The cost of the new 83-inch OLED panel. And 3. The introduction of an unannounced 31-inch OLED panel. Let's start with the 42-incher. According to DSCC, the 42-inch OLED panel from LG Display will cost 33% lower than 55-inch OLED panels. And if you look at this graph here, DSCC is predicting that a bottom emission 42-inch WRGB OLED panel cut using multimodal glass or MMG technology at LG Display's Guangzhou factory will cost $250. And in another chart, you can see that a 55-inch OLED panel produced either using MMG or non-MMG method will cost $375. $250 down from $375 is a 33% decrease. Note that these are just the cost price of the OLED panel itself. If you add in the cost price of other TV components, distribution and retail markup, the final price you see in shops actually ends up being at least 4 to 5 times higher. So assuming that in 2021, a 55-inch OLED TV will retail for around $1,500 in the States, or £1,500 in the UK, there's a reason why it's called Rip-Off Britain, then perhaps we can expect a price of around $1,000 or £1,000 for a 42-inch OLED TV. Is this still too expensive for you, or just about right? DSCC also explained how the new 42-inch OLED panels are going to be cut from 8.5G mother glass, and why MMG or multimodal glass technology is necessary to increase the glass utilization rate and therefore reduce panel cost. Rather than just talking, I'm going to draw things out to illustrate. These days, I prefer using my hands instead of just my mouth. So an 8.5G mother glass will measure 2500mm by 2200mm. A 42-inch OLED panel with an aspect ratio of 16:9 will measure 930mm in width and 523mm in height. If MMG is not used, then at most you can cut 8 42-inch panels from an 8.5G mother glass, resulting in a relatively low glass utilization rate of 70%. However, if MMG is used, you can add another 2 42-inch panels in portrait orientation, bringing the total number of panels up to 10, and the glass utilization rate up to 87%, thus significantly reducing the cost per panel. To be honest, I never realized that rotating something by 90 degrees, even if it's the same size, counts as 2 positions. Maybe something new to try out tonight. MMG is also key to maximizing the glass utilization rate when cutting 83-inch panels. So as you can see from this chart here, an 83-inch OLED panel cut using MMG technology will actually cost less than a 77-inch OLED panel that's produced without MMG. This explains why the initial leaked prices for not only the 83-inch Sony A90J, but also the 83-inch LG C1 were not as expensive as expected, coming under 5 figures either in Great British Pounds, Euros or US dollars, and certainly below 1 Bitcoin. I'm certainly interested in seeing how much of a price difference is there between the 83-inch Sony A90J and the 83-inch LG C1 when prices are officially announced. Just a reminder, the Sony A90J Master Series OLED has been advertised to be capable of higher peak brightness, whereas the LG C1 won't be getting the OLED EVO panel that's reserved for the flagship G1 series, which tops out at 77 inches. One question potential buyers of the Sony A90J will be asking is, will the 83-inch model get the higher peak brightness panel from LG Display, similar to the 55 and 65-inch models? The answer is, no one outside of Sony knows for sure right now, but what we know is that 83-inch OLED panels are cut using MMG, and MMG technology is only available at LG Display's Guangzhou OLED fab in China. Now, the Guangzhou plant uses new equipment and manufacturing techniques than the Paju factory in Korea, so I think the chances are quite good that the 83-inch Sony A90J Master Series OLED will also be equipped with a higher peak brightness OLED panel in addition to the metallic heatsink. But let's see what we find out if we manage to get our hands on this beast later this year. The final tidbit that caught my attention from DSCC's cost analysis report is the surprising inclusion of a new 31-inch WRGB OLED panel in LG Display's 2021 portfolio. The South Korean company hasn't actually formally announced a 31-inch OLED panel, but according to Mr. Bob O'Brien, co-founder and president of DSCC, who has been kind enough to give me permission to reproduce the charts you see in this video, 18 pieces of 31-inch OLED panels can be cut efficiently from an 8.5G substrate, so it certainly makes commercial sense. DSCC was even confident enough to put a cost price on a 31-inch WRGB OLED panel from LG Display, coming in at $150. One slight concern I have is that this 31-inch OLED panel is only supposed to carry Full HD resolution of 1920 x 1080. You may recall that LG's upcoming 32-inch OLED monitor, namely the 32EP950, has a UHD resolution of 3840 x 2160, but that's using a true RGB OLED panel from a different supplier, JOLED. So maybe it's the WRGB subpixel structure used by LG Display that's preventing the company from achieving higher than Full HD resolution on its 31-inch OLED panel. I don't know, is Full HD resolution enough for you on a 31-inch TV or monitor? I have reached out to LG Display to find out more about this unannounced 31-inch OLED panel and will let you know if I hear anything back. Because of all these developments, the introduction of new 42, 83, and perhaps 31-inch screen sizes, LG Display plans to sell 7 to 8 million OLED TV panels this year, which is going to be an almost twofold increase on the 4.4 million units it shipped last year. And with an increase in supply, hopefully the prices will become more affordable, allowing more people, including some of you, to enjoy OLED's outstanding picture quality for the first time. If you would like to watch more videos on next-gen display technologies, I've created a playlist here if you'd like to click on it, and I will see you in the next video.